We're bypassing the fluff and jumping straight into a high-stakes exam duel. Let's see if you can spot a grade-dropping mistake before the examiner does. Welcome to this explainer. Today we're targeting Cambridge IGCSE Physics 0625, specifically looking at how numbers, units, prefixes, and significant figures can literally make or break your final score.
Let's compare two student answers for our resultant vector calculation. One candidate wrote, resultant velocity equals 50 meters per second. The other candidate wrote, resultant velocity equals 50 meters per second at 45 degrees to the horizontal. One of these loses a critical mark, and the other secures the top grade.
So which answer secures the grade boundary? Take a guess. If you chose the second one, fantastic work. You already understand that a vector requires both a magnitude and a specific direction. It's a tiny detail, but it constantly trips up candidates and costs them easy marks.
Section 1. Why ordinary revision fails. You know, simply memorizing physics formulas just isn't enough if you don't speak the language of the mark scheme. You might know the physics perfectly, but without that precision, you're leaving points on the table. Let's dive right into this list straight from the examiner reports, showing exactly where students bleed marks due to simple errors. We're talking about missing units entirely, rounding prematurely right in the middle of a calculation, writing out vague explanations, making graph axis errors, and drawing conclusions that just aren't supported by the data. These are easily preventable, but only if you know what to look for.
Let's think about why units matter out in the real world. On a passenger jet flight deck, the crew relies heavily on their measuring instruments for the performance and absolute safety of the aircraft. The basic quantities of length, mass, and time must be measured with absolute precision, or disaster strikes. Your exam is literally a simulation of this exact real-world need for accuracy.
Before any measurement can be made, a standard, or unit, must be chosen. Everything in physics builds on these three basic SI quantities: length, mass, and time. The SI system is a decimal system, meaning units are divided or multiplied by 10 to give smaller or larger units. Any unit error or tiny decimal slip here cascades through the rest of your calculation.
Section 2. The top band answer framework. To avoid these traps, we need a massive paradigm shift from rote memorization to mark scheme thinking. We need a structured way to approach every single measurement and calculation question.
In a moment, I'll show you the hidden examiner clue that changes your calculation entirely. But first, you really need the framework that makes this clue completely obvious. Understanding the underlying structure of a perfect answer is the master key to unlocking that hidden clue. Let's break down how this builds. Step 1. You first identify the core concept. Step 2. Back it up with evidence or data from your measurements. Step 3. Apply your scientific reasoning. And Step 4. Finish it all off with precise examiner wording. This is exactly how you secure full marks on a multi-part calculation. Section 3. Escalating the difficulty. Now, let's apply this four-step framework to a constant headache for students, properly managing significant figures and differentiating between scalar and vector quantities. The absolutely crucial point is this. Many physical quantities, such as force and velocity, are vectors. That means they have both magnitude and direction. When calculating or graphically determining the resultant of two perpendicular vectors, if you don't calculate the angle for the direction, you haven't fully answered the question. You've just given a scalar answer to a vector problem. Using the powers of 10 shorthand prevents those devastating zero-counting errors and keeps your significant figures perfectly clean for the examiner. It's a really neat way of writing numbers, especially if they are massive or microscopic. Think about how 4,000 becomes 4 times 10 to the power of 3, and 0.4 becomes 4 times 10 to the negative 1.
Let's look at an even smaller value. If a measurement value is 0.004, recognizing that it's exactly 4 divided by 1,000 instantly tells you the prefix shorthand is 10 to the power of negative 3. Mastering this notation stops you from losing calculation marks due to a clumsy decimal slip.
And remember, any single measurement you take with simple devices will not be entirely accurate. It's always going to have an error associated with it. So your scientific reasoning step should always mention taking averages for small distances or short time intervals or measuring multiples. This shows the examiner you actually understand how to practically reduce the size of the error.
Section 4. The Interactive Exam Challenge. Grab your red pen because it's time to spot the error. We're going to test your eye for detail to see if you can find the flaw in a typical student response.
Listen to this carefully. A student uses a simple device to measure a small distance of 0.04 meters, but writes it out in standard form as 4 times 10 to the power of -3 meters. Did they use the correct power of 10 shorthand? What exactly went wrong here?
The flawed answer loses the mark instantly because 0.04 is 4 divided by 100, not 1,000. That makes the correct, improved top-band answer 4 times 10 to the -2 meters. It's a tiny prefix error, but it completely cascades through the entire calculation to ruin your final score.
Section 5. The diagnostic cliffhanger. Excellent work if you spotted that error. You now have the framework to dodge unit traps, handle vector directions, and fix prefix errors. But there is an even bigger trap waiting to sabotage your perfect math.
Think about it. What if you use the perfect mathematical framework, format your standard form beautifully, but answer the wrong command word entirely? If the examiner asks you to evaluate and you simply explain, your beautifully calculated vectors will still score a total 0 for failing to fulfill the specific instruction. To learn the exact command words that dictate the mark scheme, you absolutely must check out our next explainer immediately. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations.
The choice is entirely yours. Will you let a single misunderstood command word destroy your perfectly calculated answer? Click over to our command word explainer right now. Decode the examiner's hidden language and secure those top-tier boundaries. See you there.